All right. Hey guys, welcome back to the channel. Today we're gonna be focusing on moving from a fraction to a decimal, but we're gonna focus on what type of decimal it is. Is it a terminating decimal? Is it a repeating decimal? How do we represent the terminating decimal? And how do we know that it's repeating decimal, right? And that's what we're going to be looking at. But we're going to first take care of some important terms. So to do that, we're going to have the fraction 3 over 4, right? And we're just going to label this thing right here, except for the vinculum. We're not going to label the fraction bar or the vinculum. We're going to just label the numerator right here. And we have the denominator right here. So the numerator and the denominator. But remember, we're moving from a fraction. Let's put that in green. We want to move from the fraction form to the decimal, right? And to move from the fraction to the decimal, what we do is we divide the denominator into the numerator. So similarly, if you have a calculator, to achieve this, you just take 3 divided by 4 on the calculator, and out comes 0.75. But if you're going to do it by hand, right, which is what is required, right, that you know to do it with or without the calculator, right? So to do it without the calculator, we are going to identify our divisor and our dividend because we need to set it up in a long division format that looks like this. And I'm going to use red today. That looks like this. Outside here is our divisor. Underneath the division sign is our dividend. And our answer here would be our quotient. So it's important to know these terms. So when you're doing it by hand, knowing these terms really help when you get to worded problem. So if they ask you, hey, what's the quotient of 3, 4, you know that you need to divide, all right? So we need to know what's the divisor and what's the dividend when it's in this form. And we're going to look at this form as well. If it's 3 divided by 4, right? Because that's 3 divided by 4 here. So we're going to identify, I'm going to identify in red what the divisor is and what's the dividend. Remember, the divisor is what goes outside here. So we're taking 4, we're dividing that into 3. So the denominator is what becomes our divisor. And the numerator is what becomes our dividend. So when it is in this form, you could rewrite this entire thing as denominator, numerator, and still we will have a quotient right here. So we could rewrite this as well. Another form that you may see it in is outside here. Remember, it's the divisor. What's the divisor? The denominator. So we could put denominator and numerator, and then we still have the quotient, right? So whichever way helps you to remember it better, but that's what the setup looks like. When it is in this form right here, as you can see, if we're looking at 3 and 4, then 3 is our dividend. Let's write that in red, just the same. 3 is our dividend. And 4 is our divisor. So different representation, just the same thing. So you just need to know what's the dividend, what's the divisor. And that's how we know. So if we're going to move from this fraction to a decimal by hand, we need to set it up like this. So we're going to put the divisor on the outside, the dividend underneath the division sign, and the answer that we get is going to be our quotient. And remember, we're focusing on looking at if we receive a terminating or a repeating decimal. So we're going to look at that as well. Now, we're going to set that up over here, which is that 3 divided by 4. So we're going to write that fraction division sign right here, and our dividend right here would be the numerator. So that's just a 3. And the divisor would be our denominator, which is 4. And then our answer is what we're working towards, which would be our quotient. So here's what we do. We're going to use that same DMSB that we had made reference to in the earlier videos. So that's DMSB, which means to divide, multiply, subtract, bring down. So let's go. We're going to divide 4 into 3. How many groups of 4 can we get from 3? 0. Because if you have 3 things, there's no way we could get any groups of 4 from that. So that 0 goes right here in our numerator, in our quotient. Then we need to multiply. What's 4 times 0? 4 times 0 is still 0. And we're subtracting just that 0. And we are back where we started. Seems as if we haven't gone anywhere. But a lot of persons or a lot of teachers may skip this step, but I feel as though it is important because when you take, for example, the misconceptions that some students make with the decimal point, right? So they would put the non-zero digit here and then the decimal point here, and then that creates a whole misconception of where the decimal point should go. So I think by just not ignoring that step to know that, hey, that's 0, right? I mean, if you're completely proficient or fluent with dividing like this, then you'll know exactly what to do. But otherwise, if we're teaching it, I think we should just stick to the steps, all right? Now, we subtracted and we got a 3. We need to bring down something, but there's no more digits. Because remember, it's the digits in the dividend that we bring down. There's no digits in the dividend to bring down. So what we need to do to see where this number is going or what the decimal portion of it looks like, we need to put a 0 in the dividend. But if we put a 0 in the dividend, then we need to put a point. Some people say the point comes first, then the 0. But I think the 0 is what we need. So it means that we need to put a point here because we need to keep the value of the dividend just the same as 3. So that 0 here is what we're going to bring down right here. And we need to also bring a copy of that decimal point in our quotient. Don't forget that. Once you get to the point, just bring a copy of it in your quotient immediately so that you don't forget, right? Now, 4 into 30. 4 into 30, how many times? I think we can get 7 groups of 4 from 30 because 4 times 7 gives me 28. And I'm going to go left with 2 to make up that 30. So that's because I know my timetables. So 4 into 30 goes 7 times. 4 times 7 is 28. So we just divided, we multiply, then the next step would be to subtract. When we subtract 28 from 30, we're left with 2. And to see that, we're just borrowing from that left a 2, and that becomes 10. So that's what really happens. So we get a 2 right here. Now, because we already placed a point in the dividend, it doesn't matter how many zeros we put, just to see where the decimal digits are going, if it's going to terminate or if it's going to repeat, right? So it doesn't matter how many zeros we put out here, we want to see what's happening with this decimal number, right? So we're going to continue putting zeros until we either get it to terminate or it continues, all right? So we put a 0 here again, and we're going to bring that down here, and then 4 into 20, I think that goes 5 times. That's us dividing. What do we do next? Multiply. 4 times 5 gives me 20. Then I need to subtract that. When I subtract that, I get 0 as expected, because 3/4 as a decimal is actually a terminating decimal. And how we know that is a terminating decimal, it actually ends in 0. Because if we continue here, that's just a 0. And zeros after the decimal point, like out here, if a 0 was here, then it would be significant, right? But then zeros after right here, not really significant. It depends on where the 0 is after the decimal point, right? So we end in 0, so it means that this decimal number here, let's box that in red. We say that that decimal terminates. Or we call it a terminating, let's put that, terminating decimal. There we go. So we say that this decimal terminates because it ends in 0. So there's no other decimal digits other than 0 that we could get from doing this division problem. And normally when it ends like this, it terminates because it divides out nicely, right? So it means that the decimal equivalent to 3/4 is 0.75. So 3/4, let's write that in purple over to this side. 3/4 is equal to 0.75. So we have the fraction form here, we have the decimal form right here. So that is how we move from the fraction to the decimal by hand, doing long division. There's a lot of terms right here, very important. Hope you pay attention to those, especially this one right here. Denominator on the outside, numerator on the inside. Still our quotient inside on top. And if it's divisor, dividend, quotient, right? Dividend, divisor in this form. So you have 3 different forms of representing that, right? We're going to look now at what if the decimal digit continues, meaning what if we have a repeating decimal, right? And to do that, I'm going to just erase this piece right here. And I'm going to rewrite fraction right here because I want to ensure that the fraction I'm getting is repeating. So a nice one we can have is 1 over 3. Sorry. So 1 over 3. Now, what we need to do is to set it up, just like we did with the 3/4. So again, we're going to set it up like that. What goes on the outside is our divisor, which is 3. And what goes on the inside is our dividend, which is 1. And then we continue with this right here, which tells us what to do. Divide, multiply, subtract, bring down. Let's divide. How many groups of 3 can we get from 1? None, right? So that's a 0 in the quotient. Then we need to multiply next. That's 3 times 0 is 0. Then we subtract, and we are again back where we started. So there's no more digits in the dividend. So because there's no more digits, we need a 0. But because we put a 0 there and you don't want to change the value of the dividend, you need to put a decimal point right here. And then again, we're just going to bring a copy of that in the quotient. And then we bring this 0 down. So 3 into 10 goes 3 times, because we can get 3 groups of 3 from 10. And then 3 times 3 is 9. We subtract, we get 1. Let's just do it again because we know it's going to keep going. If we put a 0, we bring that down. 3 into 10, 3 times 3 is 9. We subtract, we get a 1 again. And we're going to keep getting a 1. That looks like an I. Let's make it look like a 1. So if we continue putting zeros, again, we can put as many zeros as we want just to see where the decimal digits are going. Is it terminating? Is it repeating? In this case, it's repeating. And if we continue, unless we stop, this goes on forever, right? So if somebody was paying you to say, hey, get to the end of this decimal digit, you're not getting paid because you'll never stop until you stop. So where you stop is not the end. You just need to show that, hey, this decimal is a repeating. How do we show that it's repeating? Because we don't want it to be looking like the terminating decimal, right? There's no distinction between the two. So to have that distinction, to show you when you look at this thing, to know if it's a repeating decimal, there are actually 3 notations, right? The first notation here, I'm going to write them in purple in this space right here. So to show that 3 continues forever, we put a line or a dash, we call it, at the top of the digit that is repeating, right? There may be more than 1 digit that are repeating, so you would have to put the dash over both of them, right? We could just say it's 0.3 and put a dash at the first 3. That's fine, right? But even if we put the dash over both of these 3, it would still say the same thing because I mean 3 goes indefinitely, right? But a dash over the digit that is repeating is fine. So there's 3 ways. We could write it as 0.3. Let's put 0.3 down here and put 0.3 again. And then the first notation would be a dash, just like this one. The second notation could be a dot, like that one. The third notation, no, it doesn't really indicate that, for me at least, that it's like a repeated. It says it continues. It's a ellipsis. I think they call it an ellipsis. I had to recall that again back today, right? But it says that it continues forever, right? So 3 continues forever in this case, right? But again, when you have it like looking like this, it could continue forever. But in what pattern, right? But we know that this is 3 repeating. So I prefer to use these 2 notations. Yeah, that's what I prefer to use, right? I would use this, for example, if it's a non-terminating, non-repeating, right? Right? Let's say it just continues. I would prefer to use that. It continues indefinitely, right? So, or it may have a repeating pattern, but just a long repeating pattern where you would, a calculator can't show you all the digits. You'd have to use a specific different type of calculator to get that, all right? But those are the notation that you can use to represent that a decimal is repeating. So we say that these are repeating decimals. Where I'm going to write that? We got no space. Let's erase this last notation here and just say repeating decimal, right? So that is how we differentiate between terminating decimal and repeating decimals, right? And again, there can be different repeating patterns, right? For example, 6, 7, 6, 7, 6, 7, 7, 3, 7, 2, a lot of repeating pattern. Just ensure that you put the dash to indicate that it is repeating. If you just put, for example, if you just put 0.3, that's a terminating decimal, right? You need to indicate that it is repeating, and with a dash or a dot or with the ellipsis at the end of the decimal digits, right? Thank you for watching. I'll see you in the next video.